Hey everybody, this is Jim Neeb from Jim Neeb Woodworks. Today I'm going to start working on a project that I've been planning for 2 years actually, just haven't gotten around to it. When I originally did the video, I think it was on the review of my 15 watt op laser, I cut this eagle out of some 3mm plywood, and on the video I was complaining about how when it sits on my honeycomb table it tends to warp, and when you hold it down with some like weighted pieces, as you're cutting it, it wants to warp and parts pop up. And the problem with that with the laser is it takes those parts out of being ideally focused. So you have problems where it doesn't cut all the way through in certain areas because the laser's out of focus. And one of my viewers suggested, hey, well, why don't you make your honeycomb table into a vacuum table? And at first I thought, well, how would I do that? Because typically a vacuum table on a CNC isn't a high volume vacuum. It relies on a large surface area to pull down the piece. And you need to get the smoke out of the way on a laser. If you let this sit down on a sheet of MDF, like is usually MDF is on a vacuum table, if you let this sit down on that, it's going to stain the back of this really badly because the smoke and debris are coming out of the back of this. But then I thought, well, yeah, actually I can make a vacuum table out of this easy because the honeycomb is very porous and then the other side could be vacuumed. So I'm going to modify this and add a couple of features. One is I need a little bit more height here to get the vacuum hose in the back. The second thing is I'm anticipating higher powered lasers in the near future. I'm trying to get a hold of one right now. So it'll be higher power and a longer focal length or working distance. So the reason that's important is currently the laser I have is a pretty short focal length. So this little distance in between here, between the top cutting surface and the wood, is not a problem. Because by the time I cut through and the beam hits the bottom here, it's so out of focus it doesn't have enough power to burn. But if I have a laser that's say double the power and maybe a 6-inch lens, like a 150mm focal distance lens, I'll have to be careful or it'll just burn right through this as well, and I don't want that. And I also have these 3 pieces of wood underneath to support the top here. They will also get cut right through with a laser like that. So I need to change these to like stainless steel or something. I need to put a protective layer of metal on the bottom here to prevent burn through. That'll solve that problem. And I'm going to have a pretty strong vacuum applied to this, which is, overall going to put a lot of force on this top. So these supports are going to actually need to be stronger than they are now. The other thing I want to do is surround this. I have to seal the sides up so that I don't have too much airflow, otherwise I won't have enough vacuum, so it's kind of a balance. But I do want a little bit of airflow through here because I want to suck the fumes away from the edges and back into the vacuum in the back. And I also want this to be transparent because I want to be able to see. It's really convenient to be able to see when the laser is actually getting through. It's like if you're doing a multi-pass cut, you can tell by how consistently you've got the blue light coming through whether it's cut through cleanly or you need another pass. So and you don't want to usually take the piece off of the table because you won't be able to line it up again. So it's a lot easier just to watch it and see what the quality of the light coming through is, and you can determine without disturbing anything if you need another pass or not to get a clean cut through. So I'm going to modify this and I'll show you the pieces as I build it, and then we'll see if it actually works very well or not. So anyway, hopefully this turns out to be worth the time. Alright, I took the bottom off of the honeycomb table and flipped it over and just unscrewed the honeycomb supports in the middle, and these are hard maple, and you can see they've been scarred up pretty bad by the laser here. So looking forward to the future when I get a more powerful laser with a longer focal length lens, they will get much more damage, potentially even getting cut in half. So I'm replacing these with these stainless steel. They're 1/4" by 1/2" stainless steel. Stainless steel absorbs blue wavelengths very well, so these will work a lot better. They won't be cut by the light, but they also won't reflect it into the laser, which is always somewhat of a damage risk because they do absorb, or stainless steel does absorb the 450 nanometer pretty well. Okay, this is the bottom of the top piece with the stainless steel rods or bars now notched out on the ends so that the stainless steel bars just touch the bottom of the honeycomb and support it so that there's no movement of the honeycomb when material is sucked down onto it. The idea is to have the honeycomb stay as flat as possible all the time. All right, now this picture I've added the riser blocks, additional riser blocks in the corners so that I have a larger spacing. I really only needed this because I had a 4-inch vacuum tube to fit on the back, and I didn't want the tube sticking up above the surface of the honeycomb top surface, so I just essentially made this thick enough so that the 4-inch port connection would fit between the top and bottom pieces. So I added some more risers on the corners, and then you can also see I added some cleats along the perimeter of the bottom of the top piece so that the plexiglass can be screwed to those cleats. And here we've added the plexiglass around the perimeter. It's only screwed in on the cleats on the bottom of the top piece right now, and next we'll go to looking at the bottom piece of the table. All right, here's a picture of the bottom. I made a new bottom because the original one was just a 1/4" plywood, so it was kind of flimsy, which was fine before without the vacuum, but now that I have a strong vacuum in here, I need to make sure the bottom doesn't suck up and warp, and I also just wanted it to be flatter in general, so I used a piece of 3/4" MDF instead. And then you can see I've added cleats around the perimeter like I did on the top to screw the plexiglass to, and you can see the vacuum port in the back where it fits into its groove. And then I added 3 support blocks. These probably weren't necessary, but I just wanted to make sure that the vacuum didn't suck the top down at all or the bottom up. So these are just riser blocks that fill in the gap between the inside between those 3 stainless steel bars and the bottom, and this will keep everything kind of as a nice tight sandwich. And no matter how much vacuum is on there, it's not gonna distort the top or the bottom. And the last thing I want to do to the bottom piece is add this stainless steel sheet to the bottom. The next laser I'm hoping to get will potentially be twice the wattage as the one I have, and I'm looking to get one with like a 150 millimeter lens, so that long of a focal length would easily do a lot of damage on the bottom of this MDF if I didn't have something to absorb the laser light. So I just used a piece of, this is just a stainless steel sheet meant for kind of a backsplash behind cooking stoves. It's relatively inexpensive. You could use like a sheet of copper, but the price of copper is outrageous right now. So stainless steel is a good choice. It doesn't corrode very easily. It absorbs the 450 nanometer blue light very well. You can get it in nice sheets. So in this case, I cut it out to fit, and then I just used contact cement on the bottom and on the sheet itself, let it dry, and then put it together, and it holds it down very well. So now this is pretty much, the bottom is pretty well impervious to the any of the light that comes through, or the laser beam that comes through after cutting
and hits the bottom of the table. So on this one now I have the vacuum turned on and I'm placing the final sheet of printer paper to seal the extra part of the honeycomb table. So the idea is to basically block off the open areas of the honeycomb. And you can see that before I put the last sheet on, there's essentially no vacuum because of the large hole in there, and the piece of plywood is fairly warped and is loose, especially in the lower right corner. And as soon as I put the paper in there, it holds it down pretty well. There's still a very slight gap in the lower right corner because this is a very warped piece of plywood, but it does hold it down much, much better than it used to. And it holds it down across the whole sheet pretty well too. In this one I've started cutting tests essentially to see how well the vacuum works as an air assist. So I'm turning the air assist on and off, which is essentially blowing pressure through the air assist nozzle from the laser side. And normally with the laser assist airflow turned to nothing, I would have smoke all over the place on top, and essentially the good chance of it getting up into the lenses and everything. But in this case, you can see as I'm turning the air pressure way down to nothing and back up, there really isn't any difference, and that's because the vacuum is sucking the smoke all the way through the kerf very well. And the only time that there's actually any smoke visible on the top is when it's doing that first plunge cut. So every time it moves to a new spot, it has to essentially burn down through, just like any laser has to do when it's cutting. And until it pierces all the way through, obviously it can't suck the smoke down through the bottom of the kerf until it gets all the way through. So there's a brief moment where there's a little bit of puff of smoke on the top side, and then as soon as it cuts through, the vacuum starts sucking it through, and the air assist really isn't necessary at that point. If you do have an air assist, especially if you have a very short focal length lens like this one is, I still recommend using the air assist because that's the number one best way to keep your lenses always clean, because that keeps a positive airflow going out of that lens area, and the chances of dust and soot getting up in on the lens is almost zero as long as that flow is going up there. So I would still use it, but you can cut down the airflow a lot, because now you've got a combination of blowing down from the top as well as sucking through from the bottom, which technically is, as we all know, there's no such thing as a vacuum really. It's just a lower pressure. So they're both blowing down from the top, but the application of just the ambient air blowing in because of the lower pressure down below really works well.
All right, turned off the vacuum, and this stayed down nicely. This wasn't a very good file. It's the first time I cut it. It's too small, too detailed. It actually took 2.5 hours. And most of the parts fall out, so this isn't, probably should be partially engraved and partially cut, so I have to go back and work on it. However, it did work great as far as vacuuming down the plywood. It stayed nice and flat the whole time. Nothing popped up in the middle of cutting like it used to happen to me. You know, the smoke was extracted very well. So overall, the vacuum table works really well. If you had instead, so I have a 2 horsepower 1200 CFM dust collector running this, so I could get away with pretty large holes to suck air in to extract the smoke. If you wanted to use something like a shop vac, you would probably need to make these holes a little bit smaller, but that would be fine. It really doesn't take much airflow in there to get rid of the smoke. But it's really nice in here. I don't smell much smoke at all. Normally, my whole garage would be hard to see in here from all the smoke for if I was cutting for 2.5 hours like this. So this particular image is interesting. Didn't really turn out that great, just because, like I said, the file itself is too intricate. It probably needs to be blown up significantly too. There's just some of these pieces are tiny and they're just falling out because there's not enough material left to hold it on. But as far as the vacuum table goes, which was the main purpose of this, that did work very well. So pretty happy about that.
Alright, that's the end of the video. Thanks for watching. If you have any questions or comments, please leave them down in the comment section. I always answer them as best I can. I think this achieved all my goals of getting a good dust extraction, good vacuum, good assist with the air assist, and even replacing air assist in the cases where you don't have one, and then also protecting the bottom of the table from a higher power laser with a longer focal length laser. So I'm looking forward to being able to use this with bigger lasers in the future. I'll leave a link also for the honeycomb section that I have in this table. It's just an aluminum one that I bought off of Amazon. Just a note about the honeycombs, the aluminum ones are fairly easy to damage if you drag a piece of a board or MDF across the top of them. I have seen some places where you can buy stainless steel ones, and I've been meaning to try them out just because I'm hoping they'd be a little bit more durable. But mine's about 2 years old, and I'm very careful about what not dropping things and dragging on the top, and it stood up very well. It certainly has stood up. It looks pretty nasty. It's got a lot of smoke stains and stuff on it, but I've cut a lot of different things, including several vinyl records. And none of that has really done any damage to it. It's just stained it a little bit. So it's held up well as long as you don't give it any physical abuse.